Okay, here's the homework answers. Quiet, please. Check. So questions. 33. Okay. I mean, they tell you what the pattern is here, right? They said it's a difference of squares, and we have a formula for that. I think what I'm going to do here is edit, copy, edit, paste, edit, paste. Okay. Okay. So we have some room to work on right there. Remember, the formula for a difference of squares is like this. A squared minus B squared equals A plus B times A minus B. Now that one, as you look at it, that looks like it could be a difference of squares, just like it's written right there. That could be 6x squared minus 4 squared. But the truth is there is a greatest common factor in those two. So you could factor that out before you start. What would be the greatest common factor between 36 and 16? 4. Right? So that turns this problem into 4 times 9x squared minus 4. Right? So now it's going to be, the 4 is going to be outside parentheses, and then then you're going to have your two factors. It'll be 3x plus 2, 3x minus 2. Right. Which other ones? Yeah, Shayna. 28. Okay, so before we do 28, remember that when you have a quadratic trinomial that has no common factors, even like number 27, right, then you're going to have to go through some process to factor. Now, if this number, the a in front of the x squared, is a 1, it's a simple one-step process. Just think of the factors of the last number that add up to the middle number, right? The factors of 12 whose sum is negative 8 are x minus 6 times x minus 2. Now, 28 is different because the a is not 1, and there's nothing in common that you can factor out. I mean, it's a little bit different than this one here, which the a is not 1, but there actually is a greatest common factor of 2 you could have taken out before you started. And then you'd have to go through a little bit of a process. This one is like this one, right? What two numbers, their product is 40 and their sum is 14. 4 and 10, x plus 4 times x minus 10. Now, the process that we got to go through here is like 6 steps. Just whatever you do, don't try to do these 6 steps to do these 2, right? You're going to go through all 6 steps so you can end up with the answer that you actually already knew in 1 step. And there's all kinds of chance that you're going to make a mistake somewhere in between step 1 and step 6, right? So this is the one where you got to do all of this. And if you remember, it's 3 times negative 20, that's step 1, is negative 60. Okay. What are the factors of negative 60 that add up to 11? Negative 4, positive 15, right? So negative 4 times positive 15. You might have to play around with that. I mean, 60 has a lot of factors. 1 times 60, 2 times 30, and go through them all. because that number is negative. You knew one was going to be positive and one was negative. Because that number is positive, you knew the bigger one was going to be a positive number. So in any case, we're going to use these to split up the middle term. Right, this will be 3x squared minus 4x plus 15x minus 20. Right, that's step 3. Right, notice that negative 4x plus 15x equals 11x. So we didn't change the value of anything. We just kind of reorganized it. Okay, what's the next step? Group the first two and group the last two. And then what? The greatest common factor, right? Factor it, and now it's this kind of factoring, greatest common factor. What's the greatest common factor between 3x squared? Okay, so take out an x, and what's left is 3x minus 4. What's the greatest common factor between those two? 5. So you take out a 5, and you're left with 3x minus 4. And it should always be the case that what's in parentheses is the same. If it's not, you did something wrong. You need to go back and check and see what it is. Okay, now because it is 3x minus 4 in both terms, like this is one term, this is another, they both have a factor of 3x minus 4, so we can factor that out. And what's left? What's left if I take out 3x minus 4 from that first term? X. And what's left if I take 3x minus 4 from that? Plus 5. So it's x plus 5. Okay. What other ones? 36. What's the greatest common factor between 14, negative 14, and negative 49? 7. Or negative 7. Oh, that's not right. That should be plus. Plus. Any others you want to see? Okay. Yeah. Did I get that wrong? Yeah, it's 2. 2. Yeah, that's why you got to watch me. I make mistakes all the time. Anything else? Okay, try. Okay, I guess, did I jump ahead? I did. I tell you, because I did this out of order because there's ones that are leaving. Do these as classwork right now. 20, 22, 25. Yeah, sure. One of them is a system. One of them is a system, but a graph. And one is a rational equation, which you could either solve algebraically or you could solve it as a system. Okay, let's go over this. So this is a system. What do you have to do if you're going to solve it by graphing, which is really, what ways do we have to solve a system like this? You could do substitution if you wanted, right? You could, solve it for one of the variables, substitute for that variable in the other equation, and solve it that way. Also, we learned how to solve it by graphing, right? What would you have to do to this before you could solve by graphing? Solve for y, right? So it would have to look like y equals negative x minus 10, and y equals negative x squared plus 2. Right? Now, notice the way they ask these questions now, because it used to be they would give us questions like that, and they would say, find the points that solve. And then it was easy enough just to plug in the x and the y's until they worked. Now they only ask for the x values. So you don't want to think, oh, this is a xy point and try to plug it in. There's going to be 2 solutions, and they each have an x coordinate. You are looking for the x coordinates. right? That's it. So when you put that in the calculator, it looks like here, negative x minus 10, enter, clear, negative x squared plus 2. And your graph, zoom 6, get in the middle of the graph. Now, it will only find solutions that are on the screen. So you could see the one solution that's there. When we go through this process, second trace 5, it's going to find that one directly, right? And it's negative 3. Well, there's two possibilities here. You have to figure out, is the x-coordinate of this point, which is just off the screen, more likely to be a negative 7 or a positive 4? It's positive 4. The x is definitely to the right of the middle, so it has to be the positive 4. Now, another thing you could do, and again, you got to know these things and make sure that they're in your toolbox, so to speak, right? Zoom out. If you don't see it there, just do this. Go zoom, and zoom 3 is zoom out, right? And now it really pulls back a lot, but you can see the intersection point. So now I can do the second trace and intersect 5. It just, this time I'm going to scroll over to the point I didn't already get. So it's closer to that. Enter, enter, enter. 4. So those are the 2 points. So remember how to zoom in, zoom out. How do I make it go back to where I was before? Zoom 6. Remember, zoom 6 gets you back to the middle. All right, so zoom 6. So the answer was B, right? The answer was B. Okay, here's another one. It's a system. You've got a graph. What is it asking you to do? What is it telling you to do? What's the action verb here? Click on each point that is a solution. So not just one, make sure you get them both. And how many, you see them both? They are approximately here and here. So use your cursor, click, click. Right? Make sure you read the directions. Do them all, right? Don't just do one. And then this one, I mean, this is a rational equation. And usually the way we solve something like this is you find the least common denominator and you multiply both sides by that. In this case, the least common denominator is pretty easy, isn't it? It's x. So when you multiply both sides times x, right, that means every term. Hunter, are you paying attention? Right? X times x times x, right? In this term and in this term, the x's cancel. And all that's left is 1 minus x plus 2x equals 7. And you solve, right? So that'll be 1 plus x equals 7, x equals 6. That's the answer. Now, could be solved, like any equation, could be solved with the system, right? Go into the calculator, y equals, clear. So 1 minus x over x, I'm going to use the alpha window, or y equals, 1, and that is 1 minus x divided by x plus 2, enter, and on the other side it is 7 over x, so clear. Alpha y equals 1, 7 over x. Oh, I didn't do it right. 7 over x. Okay, enter. Now, this points out something. If you're going to use your calculator to solve a system, even one that you're supposed to solve as a system, if you go to the graph, right, I mean, it's a messy graph. You see all that going on? I mean, I think I see an intersection right there, but I'm not sure what might be going on up here or over here or anything like that. Now, I go through my process, second trace 5, and notice that when you first start, it's got an x coordinate, but it doesn't have a y coordinate. So you're not actually on any graph yet. You're not on a graph until you arrow over, and now the cursor is there and it's got a Y. So now it's on one, and so you can get going. And notice what would have happened if I went the other direction. If I went the other direction, okay, I went to the left, there's the cursor now, and I hit enter. Come on. Enter, enter, guess. It doesn't find the solution because it's on the wrong side, right? The solution is not here, it's over here. So if you're clicking on these two as being the lines that cross, you're not going to find it. So you got to get out, make sure you're on this side. Second, trace 5, right arrow to get over to that part of the graph. Now it's there, and now hit enter, enter, enter. 6, just like we solved 6. Right? And you don't care about the Y. 7, 6. You know, we introduced the Y to solve it. Okay, so now that we did that, so the reason that we factor, like we did in the homework, is to help us solve equations. And, you know, we had to actually, for those kinds of factoring that we saw in the homework, plus we had sum and difference of cubes, which we've dealt with already. But you can also solve by graphing, and you can solve with quadratic formula. Remember that your solutions could be real or they could be imaginary. This is the part where they introduced imaginary solution or imaginary numbers so that we could deal with imaginary solutions. And remember this thing here, which is fairly important, right? If you have imaginary solutions or even real solutions that have a square root in them, you know that those solutions come in conjugate pairs, meaning, right, if you have 2 plus the square root of 3 as one solution, you got to have 2 minus the square root of 3. That's the conjugate, because where do those solutions come from? Quadratic formula, and it has a plus or minus in them, right? You're never just going to get the plus. You're going to get the plus and the minus. Or if it was 2 minus 3i, you would have to have 2 plus 3i, because where did that I come from? It came from taking a square root of a negative, right? That came from quadratic formula. So remember that when you're looking for solutions, imaginary solutions or even radical solutions are going to occur in pairs, and that's how you recognize the pairs. Okay, when you solve by factoring, remember that you want to have the equation in factored form equal to 0. So just to make it easier on me, let's say we started on the first homework problem was x squared minus 8x plus 12. That was a factoring problem. If that were an equation that I had to solve, right, then I need to have that in factored form equal 0. So this is in standard form. We factored it as part of the homework, right? It was x minus, do I have the wrong, that was supposed to be a 6, wasn't it? No. 6 and 2, no, sorry, x minus 6, x minus 2. Okay, and now the zero product property says that if a product equals 0, then one of the factors has to be 0. So either x minus 6 equals 0 or x minus 2 equals 0. Which means x equals 6. Or x equals 2. Right? That's how we solve by factoring. Right? Factored form equals 0, use zero product property. Okay, solving by graphing. I mean, let's say we had an equation like 3x squared plus 11x equals 20. Right? Which is kind of one of our homework problems too, okay? And we wanted to solve it by graphing. Well, we would need to get everything on one side, 0 on the other, okay? So in this case, it would be 0 equals 3x squared plus 11x minus 20. And then we would graph y equals that expression. Okay, so, I mean, we introduced the y, right? There was no y in that. So we introduced that so that we could graph it. So you go to your calculator, put in the 3x squared plus 11x minus 20, and look at the graph. Okay, what are we looking for on the graph? The x-intercepts, right? Because on the x-axis, y equals 0. It's only at the x-axis that y equals 0. So we introduced the y, but now when we find the place where y equals 0, we're solving that equation. Okay, so now, do we see two solutions? Okay, so there's one there and one there. If we remember from the homework, it was x plus 5 times 3x minus 4, I think. Yeah, so that looks like it could be x plus negative 5. How could you be sure? Well, without even doing that, just go to the table of values and look. Right? Second table, right above the graph, and then look for where the y value equals 0. If you think it's at negative 5, then scroll up to negative 5 and check. Yes, there's one of my solutions. Now the other solution, it looked like it might be around 1. So if I check 1, second table, it does not look like it's at 1. Right? There's no 0 there. Kickdown High School, Mr. Callahan, to help you. Okay. 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 Yeah, go ahead. May 22nd? Yeah, I already have that. Okay, bye. All right, bye. Sorry about that. That was my fault. Okay, so how do we find a 0 when it's not actually at one of the integer values? It's the same menu, right? Second trace, and now you go for 2 for 0, right? So 2. Okay, and it's going to ask you left bound, right bound, and then guess. So by left bound, it means if you want to find that 0, you need to put in an x value, which is to the left of that value, something less than what it looks like that is. Right? It doesn't have to be, everybody could pick something a little different, and you could either enter it by doing, just enter an x value, like negative 2, or you could use the arrow keys to scroll back and forth until you got it where you want it. But let's say I put in negative 2. And then for the right bound, I'm going to scroll just to show I can do that too. Look for the cursor, there it is. Okay, now when the cursor is there, because the line's tilted like that, it'll be a little bit to the right. It's up and a little bit to the right. So you need to have like one that was below and one was above the axis, or else it won't work. And then when it says guess, if you're happy with where you put those triangles, then you say yes. And then it jumps to the solution, 1.333, which is, as a fraction, 4/3. It was 3x minus 4. So remember that it's the x-intercepts of the graph, also known as the zeros, what you're looking for. They might also use words like solutions or roots. Right? All of those are kind of saying the same thing. And remember the relationship between a linear factor and a 0. Right? If the 0 was negative 5, right, that was the 0, then the linear factor is x plus 5. Or if the 0 was 4/3, the linear factor is x minus 4/3. It's always x minus the 0, that's the linear factor. Okay, solving with the quadratic formula. I have to enter this in here, black. If you have a quadratic equation, it's in the standard form equals 0, not factored form, right? And the coefficients of the squared term and the linear term and the constants get plugged into here, A, B, and C. So for example, 3x squared plus 11x minus 20 equals 0. What would be the values of A, B, and C? Guys paying attention? Okay. A, B, and C. Remember, you don't put in the x's. You only put in the numbers. 3, 11, negative 20. And you substitute it into that formula. Okay. Now, if you do, you can simplify. You guys are pretty good at doing that. You could put it in your calculator too. Right? You can do the quadratic formula in the calculator. Store A equals 3, B equals 11, C equals negative 20. And then enter this formula using the alpha keys in the calculator. It'll work. Right? Now, this part, the part that's underneath the radical, not the radical itself, has got a name. It's called determinant. Right? The determinant, the value of the determinant tells you whether or not you should be expecting real solutions or imaginary solutions. And if it's real solutions, how many? As we've seen before, when this is a real number, a number greater than 0, then what happens when you take the plus or minus? You get 2 real number solutions. As long as you're taking the square root of a positive number, you're going to get 2 real solutions. Right? Greater than 0, 2 real. Okay, what would you get if it was equal to 0? Then you'd have the square root of 0, which is 0. And what do you get when you add or subtract 0? The same thing, right? You get one answer, actually. So when the discriminant equals 0, 1 real answer. And if the discriminant, b squared minus 4ac, is less than 0, then you're taking the square root of a negative number. What kind of solutions do you get? Imaginary, right? So less than 0, imaginary. Yeah.
Is it possible to have one imaginary solution and one real solution?
No, because how many solutions would you expect from a quadratic equation? 2. But we said imaginary solutions have to come in pairs. So there's no way for you to have one imaginary and one real. I mean, even the one real here, it's not really one real. It's one number repeated twice. But it's the way they expect us to understand it is, if this is equal to 0, you have one real solution. Okay, so try these 4 problems. They are all related to that. And then we're getting close. Those 4. So what did you say was the answer on this one? The 4th one? And how did you get it? You just put in the quadratic formula and simplified it all the way? I mean, one thing I would say is if you start putting it in the quadratic formula, right, x equals blue, negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? I start putting those numbers in. Let's see, I got to do this. X squared plus 4x minus 16 equals 0. Right? I'm going to get negative b is negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 16 divided by 2 times 1, right? Which is going to be negative 4 plus or minus the square root of 16. That was a negative, right? 16 plus 64, which is 80, divided by 2. So right away, which answers could we eliminate? I am not even going to simplify anything more. I can tell. There's no imaginaries because we're taking the square root of positive number. Is it going to be plus or minus 4? Now, we can easily eliminate that one. And so it's only a matter of, is it this one or is it this one? And what's the only difference between those two? Whether that's positive or negative. And look at that. Is it positive or negative? Negative 4 over 2 is negative 2. So it's this one. Right? Okay, how about this one? This is the easy one, right? What was the answer? It was A, right? Okay, quiet, please. Quiet. Okay, if -3 is the 0 or the solution, what's the linear factor? Again? X plus 3, right? And there was another 0 on there. What is it? 1, right? It wasn't in our list here, but if 1 is a 0, what's the linear factor? X minus 1, right? So that could be our solution, or it could be y equals that. Okay, how about this one? If you got one solution to a quadratic, which is 13 minus 11i times the square root of 7, which of these must also be a solution? Say again? Still didn't hear you. Which is the other solution? Okay, it has to be the conjugate of this, meaning this, but instead of a minus there, a plus. Which is it? It's B, right? It's B. Okay? Hey, it's not that complicated. Okay, believe me, I see that kind of mistake all the time. You got to know what's the conjugate. What's the other thing I'd say about this one? A solution to the quadratic equation, which it must be. That's actually a kind of a bad question in terms of the people who wrote this for the SOL. That there's something technically wrong about the question. The only way you would know for sure that has the conjugate as a solution is that the coefficients of the equation you're solving have to be real numbers, right? Because it would be possible. What if one of the coefficients was an imaginary number? Well, then you could have an odd root like that. So it's not, they should have worded it a little different to be technically correct. And then this one, which of the following describes the roots of the equation? What did you say? A? And how did you get it? You did the discriminant, right? So if you get everything on one side, and 0 on the other, then remember, you don't have to do the whole quadratic formula, just the b squared minus 4ac, the discriminant part, right? So that'll be -6 squared minus 4 times 9 times 1, which is 0. So when you have the discriminant 0, because the square root of 0 is 0, plus or minus doesn't make any difference. You just get one real number answer, which is this one. Now, remember that you can do that also with a calculator. I mean, just look at the graph. Look at the graph. You can tell whether it's which one of those solutions, which one of those answers is correct. 9x squared minus 6x plus 1. Right? I zoom 6, make sure I'm in the middle. And notice the graph comes down, it touches the x-axis at one place and goes back in the same direction, one real solution. You know, we saw before, like this graph, that's what it looks like when there's two real solutions. What would it look like if there were no real solutions, two imaginary? Go ahead. Yeah, it would be a parabola opening up, which is above, or a parabola opening down, which is below. It never crosses the x-axis. So that would answer that question for you, too. And, of course, this answer could never be true. Have to occur in pairs. Okay. Now, there's two more questions. There's going to be questions like this on the test, so you got to know how to do it. One of them is like this. It's asking about intervals of increasing and decreasing, right? If you're looking at the graph of a function, it's increasing when it's going up from left to right. Like this function, the graph is going up from here until that point, and then it's going down until that point, decreasing, and then it's increasing again. When we talk about where is it increasing or decreasing, we're talking about the x values. These are intervals of x, right? So we're going to have to find the x values on the left and the right side of where is it going down. This one is asking for decreasing. So put it in the calculator just like it is and see if you can see where it's increasing or decreasing. X minus 1 times x minus 4 and look at the graph. Okay, do you see the piece of that graph which is going down from left to right? It's right in here, right? But now all we care about, what are the x values on the left side of that and the right side of that? What's the x value here? 2, and the x value here? So in between 2 and 4, decreasing. 2 and 4, decreasing. Right? You can't tell that by looking at the equation. I mean, what you could tell by looking at this equation is that it's got zeros at 1 and 4. But that doesn't help you find the intervals, right? You have to look at the graph. And then make sure you're giving x values, not y values. And then one more, and that is this kind of a function, which in fact, you could do that in your calculator. You see this? It's got a series of lines. It's number 36. There's a line, it's a segment, 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 segment. You could see it a little better on your copy than you see it on the screen here. But on the left side of each segment, it's an open circle. On the right side of the segment, it's a closed circle, right? So the y value for every point on that segment is whatever the y value is, whatever that line is, which is 1. And then every point on this segment has a y value of 2. So what would you say is the range of that function? 1, 2, 3, 4, right? There's no values in between. It's just at those levels. 1, 2, 3, 4. That's the answer. What would you say is the domain of that function? Not in the question, but what would you say is the domain? Trey? Okay, so Trey is saying it's 0 to 8. Is there any break in the graph, in the domain of the graph? Like at 2, is there a break? No, because it's perfectly covered, right? At 2, it's included there, but not there. But it is included in one or the other at 2. So there's no breaks from there to there. So let's say I was going to say 0 on one side and 8 on the other and x in the middle. What inequality symbols go here and here? It's greater than 0 here, not included, right? It's not or equal to because that's open circle. What about the 8? It's closed circle on 8, so it's less than or equal to. Okay? Again, that is a function in your calculator. If you go to clear math, num, I think it's num, is it? Let's go here. Int, math num 5. So if I go 5, and then I put an x in there, x, and then I hit graph, and you get all those steps. It's called a step function. And it is one of the ones we're supposed to be a little familiar with. The book really doesn't have much about it. You know, it's the most, you might see one. I don't think it'll be a big deal. But. So again, we're going to take our test on Friday. There's 25 questions. These are 25 questions from your package, which are just like that. So that's what you need to study. You can take that with you into the test. Yeah. Number 10. Okay, let's look at number 10. Yeah, you know what? I don't think we did 10. But I mean, it's a factoring problem that we could have done. Let me go like this. So this is going to be a factoring. It's a quadratic, factor the polynomial. Two of these are factors, and it's one of those. It's one of those grab. You're going to grab two of those and put them into the box. So, you know, if this looked a little bit different, if you didn't have y's in there, it would look like this: 8x squared minus 18x minus 5. And then that would be one of those that you've got to go 8 times negative 5 is negative 40, right? What are the factors of negative 40 that add up to negative 18? Negative 20, positive 2, right? So you would go 8x squared minus 20x plus 2x minus 5. And then you would group these two, group those two, and take out the common factor, 4x times 2x minus 5 plus 2x minus 5, which is 4x plus 1 times 2x minus 5. Now, the difference is I took out the y's. There are y's there. So instead, it should be like this: 4x plus y times 2x minus 5y. So 4x plus y here and 2x minus 5y here. So these are the two that go in there. Now, you could, in that, there's not that many factors. You could have just done a guess and check. You know, you could take, let's say, if I put x plus 5y here, then the other one would have to have 8x as the first term, so that 8x times x is 8x squared, right there. So just FOIL it and see whether you get the right thing. It won't work, right? Then you could try the 2x minus 5, which is correct. Right? If it's 2x for the first term here, that means the other set of parentheses is going to have 4x as the first term. And there's actually two of those, so you need to try them both and see which one works. So you could either solve it or that. And then, again, just like we say, let's say that you pick the wrong one, 4x plus 5y. If that's your answer, you could always store a value for x and store a value for y and see, does this equal this? That could be your ultimate check. Okay. Does that help, Rebecca? Yeah. Sorry about that. I did forget about that.